Hello everyone, this is Khairul Alam Shobuz from All Math Matters. Welcome to my online math class. Hello guys, welcome to my another new lecture. So in my lecture I will discuss about a very important topics for both A level and O level, that is series. So I'll try to discuss all the possible formulas and also some examples from these topics. First, for understanding the series, you must need to know what is the sequences. So what is the sequence or sequences? So a sequence is a set of numbers written as in particular order. Okay, so if we look at the example of this sequence, then we can see number 1, it could be 1, 2, 3, 4 up to n. So this is the sequence of a natural number. Number 2, it could be 1, 3, 5, 7 up to 2i n negative 1. So this is the sequence of n odd numbers, n positive odd numbers. Number 3, it could be 2, 4, 6, 8 up to 2i n. So this is the sequence of n positive even numbers. So this is the sequence. Okay, so for writing the sequence you must use the comma. So okay, now the main part of my lecture is series. So now we learn what is the series. So if I write the definition of series, so that will be a series is a sum of the terms in a sequence. That means if you add all the terms of a sequence, then it will make a series. So example, so here I'll show some example of series. So number 1, it could be 1 plus 2 plus 3 plus up to n. So this is a series of n natural number. Okay, number 2, it could be 2, 4 plus 6 plus up to 2i n. So this is the series of n positive even numbers. Number 3, it could be 1 plus 3 plus 5 plus up to 2i n negative 1. So this is the series of n positive odd numbers. So these are the examples of series. So in that way you can write any kind of series. So okay, now we will learn what are the important parts of this series. So this is the main part of my today's lecture, and also we'll focus on these two things, that is number 1, arithmetic progression, or in short you can tell it AP. Number 2, geometric progression. or in short you can tell it GP. So now we will learn in detail of these two progression, that is, one is arithmetic progression and another is geometric progression. Actually most of the question of your exam will be come from these two topics, that is arithmetic progression and geometric progression. Okay, first I'll discuss about the arithmetic progression. Okay, so what is the general form of a arithmetic progression? So the general form of any arithmetic progression is a plus d, a plus twice d up to a plus a negative 1 multiple d. So this is the general form of any arithmetic progression. So if you look at carefully in this progression, so here all the difference of each terms are same. So if you look at, so here a is called first term of this AP, and here D is called common difference of AP. So here you must need to know two things, one is the first term, another is the common difference, then you can easily make any arithmetic progression. So how it comes D? If you subtract the previous term from this term, that is a plus d negative a, then it should be d, a plus 2d negative a plus d, it should be d. That means the difference should be same, that's why it is called common difference. So now we will learn some formula of this arithmetic progression. Okay, so if the question asks you to find the nth term, that is the number of which term is this, then how we can find it? Okay, so then nth term, or you can say this is the last term of this arithmetic progression, should be L equal a plus n negative 1 into d. So this is the general formula for finding the nth term. So if the question asks you to find the 10th term, so here n should be 10. If the question asks you to find the 6th term, so here n should be 6. Okay, next formula, this is number 1. So number 2, sum of first n terms. Okay, so we can write it like that, Sn, S for sum. So the formula is n over 2 twice a plus n negative 1 multiple d. So this is the formula for finding the sum of first n terms. So this formula can be written in short, that is n over 2. So if you use the last term, that is L, we can write here we can write from here, that is a plus L. So if you calculate one step, that means if you write 2a equal 1 a plus a, then you will get a plus n minus 1 into d. So a plus n minus 1 into d equal to L. So we can write in short n over 2 a plus L. So if you know the last term of the arithmetic progression, then you can easily find the sum of these all terms. So these two are main formula for arithmetic progression. Okay, now I'll show some example of this arithmetic progression and also the question types. One example from arithmetic progression, what will be the question types in your exam? So if the question is find the sum of 23rd term, find the sum of 23 terms of the AP, which is 4, -3, -10, so up to infinity. So what will be the sum of this sequence? That is, if you take the 23 terms from this sequence, then what will be the sum? So for finding this sum, you must need to know types of this progression. So this is the arithmetic progression. So how you make sure it is a arithmetic progression? You first find the first term, that is a equal 4, and then find the common difference, that is d equal -3, -4, that is -7. So it means that this sequence is in a descending order. That means it goes to large number to a small number. So keep in mind, the sequence can be in the ascending order or the sequence can be in the descending order. So this sequence in the descending order. So we already know that the first term value of a, that is 4, and common difference, that is d equal -7. Now you can easily find what will be the sum of 23 terms of this arithmetic progression. Okay, so by using the formula, so sum of 23 terms equal, so formula is n over 2, that is 23 over 2, 2a, that is a equal 4, so 2 multiple 4 plus n minus 1, that is 23 minus 1, multiple d, that is 7. So it should be 23 over 2, 2 4s are 8, and if you do the multiplication here, plus minus, plus multiple minus minus, 23 minus 1, that is 22, multiple 7. Okay, if we do the rest of the calculation, then we'll get 23 over 2 multiple 8 minus 7 to the 14, 7 to the 14, that is 1 5. So it should be 23 over 2 multiple -146. So it should be 23 multiple 73, -73. Okay, if you do the multiplication by using the calculator, so the answer should be 1679. So that means this is the sum of first 23 terms of this arithmetic progression. Okay, in that way you can easily find the sum of any terms, any number of terms. Okay, now I'll show another example from arithmetic progression, that is example 2. So if a arithmetic progression is given like that, 4 plus 7 plus 10 plus. So this is an arithmetic progression because here the difference are same. So 7 negative 4, that is 3, 10 minus 7, that is 3. So that means here the common difference is 3. So that's why this progression is an arithmetic progression. So if the question is what is the 20th term, or number 2, find the sum of first 10 terms. Okay, so first you need to know what is the value of a, that is what is the value of first term, and also the common difference. Then you can easily solve these problems. So here if you look at here, the first term a equal 4 and difference, that is common difference, equals 7 negative 4, that is 3. Okay, now you can easily solve these two questions. So number 1, what is the 20th term? So 20th term should be by using the formula. So 20th term equal a plus, here n means 20, 20 minus 1 multiple d. So here the value of a is 4 plus 19 multiple 3, or you can write 4, 19 3s are 57, that is 61. That means here the 20th term of this AP should be 61. So I think this is so easy if you know the formula and also the value of a and d. Okay, now we will solve number 2. What is the sum of first 10 terms? So S10 should be 10 over 2, 2 multiple 4 plus 10 minus 1 multiple d, that is 3. Okay, now if you work out this problem, then you'll get 5 multiple 2 4s are 8, 10 minus 1, that is 9 multiple 3, that is 27. Okay, so if you do the rest of the calculation, 5 multiple 8 plus 27, that is 35. So it should be 5 5s are 25, 5 3s are 15 plus 2, that is 17, 175. That means if you add the first 10 terms of this AP, then the answer should be 175. So look at, by using the formula you can easily find the any question. Okay, now I'll show some more formula from this arithmetic progression. So you just try to keep in mind this formula because I think it will help in your exam. So the formulas are number 1, 1 plus 2 plus 3 plus up to n, that is sum of first n natural number, that should be n multiple n plus 1 over 2. Number 2, 1 plus 3 plus 5 plus 2n minus 1, that is the sum of first n odd numbers, so the formula is n squared. Number 3, 2 plus 4 plus 6 plus 2 is n, that is the sum of first n even numbers, that is n into n plus 1. So these are the some formulas in arithmetic progression, and you can keep in mind these formulas. I think it will be very helpful in your exam, because if the question is like that, what will be the sum, by using this formula you can easily find the sum, and I think it will take only few seconds. Okay, for an example, if the question is 1 plus 3 plus 5 plus 7 plus 9 equal what? So look at how many terms of this odd consecutive numbers, that is only 5 times, so sum should be 5 squared, that is 25. So look at, this is so easy. By using this formula you can find the sum so quickly. So you must keep in mind this formula. I think it will be very helpful for your exam. Okay, next we will learn the geometric progression. Now our next part, that is number 2, that is geometric progression. Or in short you can tell it is GP. So now we will learn the what is the general form of this geometric progression and the all possible formulas of geometric progression. Okay, so the general form of the GP is A plus A multiple R, A multiple R square, A multiple R cube up to A multiple R to the power n minus 1. So if you look at here, first term equal A, and here all the ratios are same. That means if you divide the second term with the first term, that should be R. If you divide the third term with the second term, that should be R. That means all the ratios are same. That's why it is called common ratio. So it is called common ratio, that is R. So in our last topics, that is in arithmetic progression, we learned that is common difference, but in geometric progression you must know that is common ratio. Okay, now we will learn some formula from this geometric progression. Okay, so number 1 formula is n term of GP. So the formula should be A R power n negative 1. So if you know the value of A and R, then you can easily find the any term of the given geometric progression. Okay, number 2, sum of first n terms of GP. So what will be the sum of first n terms of GP? So then you can write it like that: Sn equal A multiple 1 negative R power n over 1 negative R. So keep in mind here R cannot be 1. That means R not equal to R must be not equal 1. So and also this formula for if R less than 1. Okay, if R is greater than 1, then what is the formula? Then the formula should be Sn equal A multiple R power n negative 1 over R minus 1. So if R greater than 1. So these are the formulas in geometric progression. So keep in mind, if R less than 1, then you must use this first formula. If R greater than 1, then you must use the second formula. But here R cannot be 1, because if the value of R is 1, so it cannot be possible, because if you use here R equal 1, so in the denominator 1 minus 1 equals 0, so something by 0, that should be undefined. So here R cannot be 1. Okay, now we'll see some example. Okay, now I'll show some example of geometric progression, actually the question pattern. So for example number 1, if a geometric progression is given like that, 2, 4, 8, 16 up to infinity, that is, this progression is continued. So if the question is number 1, what is the 10th term of GP, and number 2, sum of first 6 terms of this GP. Okay, now here it is also very easy. You just look at what is the value of A and what is the value of R. So here the first term A equal 2 and the common ratio, that is R equal 4 divided 2, that is 2. So now you can easily find the 10th term of this GP. So 10th term should be A power R to the power 10 minus 1, that is, here just consider 10 as a n. So you now just put the value of A and R. So both A and R are 2, so you can write 2 power 10 minus 1, that is 9. Ultimately there is 2 power 10, so which is 1024. So that means the 10th term of this GP should be 1024. Okay. Okay, now what will be the sum of first 6 terms? Okay, that is A6 should be. So look at here, the value of R is greater than 1, which is greater 1. Then the formula should be A multiple R to the power n minus 1 over R minus 1. Now you just put the value of A, R and n. Here n should be 6, so that should be 2 multiple 2 power 6 minus 1 over 2 minus 1. So if you do the rest of the calculation, that is 2 multiple 2 power 6, that means that is 64 minus 1 over 1. If you do the calculation, that should be 126. So this is the sum of first 6 terms of this given GP. So I think in that way you can easily find the question, that is, what is the given terms and what will be the sum of given first terms. So I think this is so simple if you can memorize the formula from GP. Okay. Okay, now we will learn the convergence of geometric series. So that is convergence of geometric series. Okay, so this is so important. For an example, if a series like that, 1 over 2, 1 over 4, 1 over 8, 1 over 16, you can get an idea what is the convergence. That now you can get an idea this series converges to where. So now look at this series converges to 0, because 1 by 16, then next term should be 1 by 32, like that it should be converges to 0. Okay, so actually this is the infinite series, because we don't know how many terms of after this, it could be infinite terms. So for this infinite series we can learn a formula for finding the sum of these whole terms. Okay, so the sum of infinite series. So you can say that is s in here, s infinity equal a over 1 negative r. So here must you need to know the condition of the value of r. So here r must be lies between -1 to +1. Otherwise you can't use this formula. If the value of common ratio is -1 to +1, that means greater than -1 but less than +1, then you can use this formula. Otherwise you can't use this formula. Okay, now if you find the what is the sum of this infinite series, then you can easily find this, because here a is 1 and r equal half over 1, that is half. Okay, so now if we do the summation, that is s infinity, it should be a over a, that is 1 over 1 minus half. So 1 over 1 minus half, that is half. So 1 multiple 2 over 1, that should be 2. That means if you sum all the terms of this infinite geometric series, it should be 2, because here the first term is 1, and if you add the next of the, so now if you add the rest of the terms, that should be 1. So 1 plus 1, that should be 2. So in that way you can easily find the sum of infinite series of any geometric series. Okay, so these are the all formulas in series. So if you practice all the formulas properly at home, then you can easily solve any problems from this series. Actually two important things, that is AP and GP. So I believe that if you watch this full lecture completely, then you can understand and you can learn the AP and GP quite easily, and you can also solve the any problems from this series. So this is the first part of my lecture. In my next part, that is in part 2, I'll explain all the previous questions from this series. That means all the question about AP and GP. So thank you everyone for watching this lecture.